Hello everybody, this is Rolf Bienert, Technical and Managing Director of the OpenADR Alliance. I'm happy to be here today to give you a brief introduction to the OpenADR standard. After that, Stan will continue to give you more information on OpenLEADER and how to actually implement the OpenLEADER open source protocol into a product. So let's hop right in. Basically, OpenADR is a non-proprietary open standard to communicate between demand response service providers and resources downstream. So this is typically done through a secure internet connection, which can already be available at the customer side, or of course, it could be done through a dedicated link like a cellular modem or things like that in rare cases. Typically, however, it uses already existing internet connectivity. The OpenADR signal can also be sent to an aggregation point. This aggregation point can be either an aggregator company, or it could just be simply a facilitator that receives the signal and spreads it out to other devices. For instance, you can imagine this like a cloud-based thermostat control. That being said, OpenADR has been around for quite a while. In fact, since about 2002, when the concept was conceived in California after the energy crisis of 2001. So it's been around a while, but we have improved it over the years, and since 2013 now, we have the final specifications. We are, however, always looking at improvements and making sure that things are going the way they should. OpenADR by now is also an IEC standard listed there, and you can purchase it at the IEC as well. So let's look a little more at the concepts behind OpenADR. We are seeing, I should say, two different players here. The virtual top node, the VTN, and I believe Stan will also mention these names, so it would be good to take a good look here. And the virtual end node. The virtual top node is a server that manages all the resources. It will create and transmit event messages using OpenADR to the resources out in the field. It can also request reports back with feedback from these resources. The clients, the VENs, consequently, are part of the resources out in the field, and they can receive these events and will respond to them. All messages are peer-to-peer. There is no networking involved at this point. The services of OpenADR primarily include the event service, which is very similar to a calendar notice. So you have a start time and an end time, and you can send a number of different information elements in there, from price information all the way to specific energy requests. Everything can be embedded in these event messages. There are a few other services here, but most important, aside from the event service, is the report service, which provides feedback from the resources upwards. Everything is XML payloads, and we secure the links with a TLS 1.2. Typically, we have seen in the past efforts to flatten the peaks in a grid connect system, really only to manage the times where there is too much load on the network. That was the initial idea behind OpenADR starting in 2001 and 2002. However, by now, we are seeing much more out in the field, and OpenADR is being used to send all kinds of control commands to control systems that in turn can then manage other systems like storage, like EV chargers, microgrids, and so on and so forth. So all of this is being discussed these days, and a lot of it is already implemented. One example here, for instance, is electric vehicle charging systems using OpenADR to send prices or specific energy requests, and then OCPP from the charge station management system to the chargers. Thank you very much, and I'll turn it over now to Stan for his in-depth presentation of OpenLEADER and how to implement OpenADR.
Welcome. Thank you, Rolf, for that introduction to OpenADR. My name is Janssen, and I will show you all about OpenLEADER. OpenLEADER is a Python package that allows you to quickly integrate OpenADR communication into your existing or new projects. It supports both clients and servers, so you can create both ends of the communication, either for testing or pilots, or whatever suits your application at the moment. It's great for prototyping, fast iteration, pilot projects, and exploration, but it's licensed under the Apache 2.0 license, which means it is also applicable for commercial use. Let's dive right in. How can you create an OpenADR VEN or client using OpenLEADER? Well, you need to take these 4 steps. You create an OpenADR client with some basic information about your VEN and the VTN that you want to connect to, like your VEN name and the VTN URL. Then you tell the OpenADR client which reports you can provide, and you provide a callback function that can generate the values. You give it a handler that needs to be called whenever an event comes in. And that's it. That's all you need to do. Registration, message encrypting and authentication, polling for updates, delivering reports, all of that is taken care of by OpenLEADER. Now, what does it look like? This is how you can get started. You import the OpenADR client from OpenLEADER. You create a client with a VEN name and a VTN URL, and you run it on the Python async.io event loop. That's it. Now, after you run this client, here's what happens. The VEN will first do a OADR query registration, which asks the VTN which protocols it supports and some other meta information. And the VTN will reply with a OADR created party registration message that tells you all about the VTN. Then it decides to register to this VTN with the VEN name. The VTN will check it and will do some validation and authentication, and it will give you a unique VEN ID and a registration ID. Now, you don't need to remember those IDs. Those are remembered by OpenLEADER, and they are incorporated into all of the messages that you send out. And then the VEN will automatically start polling for new messages. So every, for instance, 10 seconds, it will ask the VTN, do you have anything new for me? And it can either say no and you get an empty response, or it can say, yes, I have an event for you. And then you can get to work dealing with that event. Now, for security, you would not just use plain HTTP without any form of authentication. So you use HTTPS and you use client-side certificates. And by simply adding these 3 lines, you automatically add TLS encryption over the connection, and you automatically sign your XML messages so the VTN can be sure that they weren't tampered with in transit. And if you also want to check that the messages from the VTN are actually from the VTN you think it is, you add their fingerprint and it will automatically validate that. So this takes care of all of the security of your communications in a very elegant way. Now, the client is now connected and securely connected, but it's not doing anything useful yet. So let's add some reporting. The only thing we need to do is add a report. So client.addReport. We give it a function, a callback function that can generate the values. In this case, it reads an electricity meter. We tell it what resource it applies to and what the measurement is. In this case, it's voltage. And at what sampling rate we can supply these measurements. And that's it. What happens now after registration is it sends a create report to the VTN that contains your newly created report. The VTN decides if it wants the report or not, and it lets you know. And if they want it, the OpenLEADER VEN will automatically set up the scheduler that will call your function to retrieve the values and send off the reports to the VTN. and then the VTN just receives the values, which is pretty straightforward and pretty simple. And it only took a few lines of code. And this part in blue, of course, happens over and over at the requested report interval. Now we're sending out reports, but now we also want to handle events that come in. So we add a handler for the onEvent event. In this case, your handler will simply receive a dictionary that contains all of the information on the event. And you can unpack it, you can look at the signals in the event, you can look at the individual intervals in the event and the values that it sets. And in this case, we tell a hypothetical control device to execute this schedule in the future. And we only need to return opt-in or opt-out. So if you are taking part in this event, you return opt-in, and otherwise you return opt-out. And OpenLEADER will send the correct response to the VTN. And that's it. Now you've integrated registration, reporting, and event handling into your VEN in just a few minutes and just a few lines of code. And all you need to do is focus on your own device control model, which is pretty great. Now let's take a look at the other side. Let's take a look at the server, the virtual top node. It's pretty similar. You create a OpenADR server with a VTN ID. This is how you identify yourself to the events that connect to you. And you run it. And now clients can connect, but there's nothing much interesting happening. So we need to implement three things, which is the registrations, the reporting, and the events. So we add a handler for the party registrations. This will be called whenever a party sends a yes, I want to register, and this is my VEN name. It calls your callback function with the registration info. You look it up in your database. I implemented a very dummy implementation here that simply checks for one VEN name, but you would go out and look up in your database or something. And if you agree to this, then you return a VEN ID and a registration ID to the VEN. That's all you need to do. The OpenADR message will be packed up automatically. Or if it's not allowed, you simply return false and it will reject the client. Now then the client is probably going to offer you some reports. So you add a handler on register report. And if you make this handler have the signature of resource ID, measurement, unit, scale, minimum and maximum sampling intervals, then you get each measurement as a separate call to that function, and for each of those measurements you can decide, do I want this or do I not want this, and at what interval do I want to receive these reports. And you return a handler that will be called whenever one of those reports comes in, and you return a sampling interval. And that's it. Now, once the VEN starts sending you these update report messages, your store voltage handler in this case will get called with the data. It receives a list of time value pairs, and you can put them in a database, or you can analyze them, or you can do whatever you want with them. Again, in just a few lines of code. Now that we received the reports, you probably want to send out some events, and that couldn't be easier as well. The only thing you need to do is call server.addEvent. Add your event details in there, so for which VEN is this event meant, and what type and name of the signal, and what are the intervals that you're going to give it, and what is the target of your event. And you also give it a callback so that once the opt-in or opt-out response comes in, you'll be notified if the event actually took part in it or not. Again, it's very simple. And this event will be put onto a queue. And whenever the VEN does the poll, the automatic queuing mechanism will supply this message to the VEN, and everything else happens automatically. Let me give you a short demonstration of OpenLEADER in action with an actual VTN server and a VEN that controls a controllable device. Alright, so here I've prepared a demonstration setup. containing an OpenADR VEN right here. This is a Raspberry Pi that is running the OpenLEADER software, which is connected to this energy meter, and it's connected to this switch, which controls this flexible device. We also have a non-flexible device, which is controlled by a manual switch, and everything is powered by the electricity grid. Now, I've designed it in such a way that turning on these devices will lower the voltage on this part of the grid, and that's something that we report to the VTN. And the VTN is set up to receive these reports. It looks at the voltage that is being reported, and whenever it exceeds 230 volts, the flexible device can turn on, and whenever it dips below 215 volts, the flexible device has to turn off. All right, let's see it in action. Let's turn on the non-flexible device, and let's start up the VEN. Now, in the charts on the left, you can see the metering data that is coming in, and this is what the VEN is reporting to the VTN. As we can see, we're now using about 4 watts, and the voltage is just below 230. So this is all good, but it's too low for the flexible device to be turned on. All of this reporting is fully automatic. The only thing we needed to do was register our reports, set up a handler that reads the energy meter, and everything else happens automatically. Now, watch what happens if we turn off the non-flexible device. The voltage goes up to above 230, which triggers an event, and that event says you can turn on your flexible device, which just happened. And although that caused the voltage to drop below 230, that's no problem, because that's a safe area for the voltage to be. If we now turn on the non-flexible device, you'll notice that the voltage dips below 215, which triggers another event that says you have to turn off your flexible device, and the flexible device turns off. You can also see the status, which is nicely reported in the bottom chart, the yellow one. And this is how easy it is. So we've got all the facets of OpenADR up and running here. We have reporting, we have events, we've had the whole registration part, which we didn't even see because it happened automatically. And it's very easy to just link this up to your existing infrastructure, whether it be physical devices like this energy meter or this switch, or whether it be your existing infrastructure like this time series database that I'm connecting to on the VTN side. One more time, if we turn off the non-flexible device, the voltage will again rise, which will trigger an event, and that event will say you can turn on your flexible device now, and that's what happens. So, fully automatic, completely compliant OpenADR, and super simple to set up. I hope this gives you a taste of what you can do with OpenADR and with OpenLEADER. Now that you've seen what OpenLEADER can do and how easy it is to get started, please help us make it even better. You can find us at openleader.org, and you can find us on GitHub at github.com/openleader. I also would like to thank all of the other open source developers that helped make this what it is, particularly the developers of LXML, AIO HTTP, and Jinja 2. Those are at the heart of the OpenLEADER package. And of course, this entire video presentation was also made using open source software, so thank you for that. In closing, I'd like to thank the Linux Foundation Energy for their support and their outreach. And I would like to thank eLaTNL and the OpenADR Alliance for their technical support as well. Thank you very much for watching this presentation, and we hope to hear from you soon.